Hello, everybody. Welcome to ICT Clinic. Today, the topic that we are going to consider in ICT Clinic is computer memory. Computer memory. What is computer memory? Computer memory is the physical device used to store programs or data on a temporary or permanent basis on the computer system. It's as simple as that. Anything that is responsible for storage of information on your computer is your computer memory. We have several types of computer memory. We have two. The first type is the primary memory. When you talk about the primary memory, it is the one that is directly accessible to the CPU, and it is used to store data or hold information that are currently in use on the computer. When you talk about the primary memory, it is the inbuilt memory of your computer, the one that you cannot remove. That's your primary memory. Now, we have categories of primary memory. The first category of primary memory is the random access memory that we know as RAM. You see, when you talk about RAM, it's a temporary storage that is used to hold information for a short period of time. Now, when there is a power outage or when the computer loses power, the RAM loses its information. That's why we say that the RAM is volatile. That is, it doesn't hold information for long. Then we have the read-only memory. When you talk about the read-only memory, which is also known as ROM, we see it as a type of memory that is used to hold information permanently or as long as the user wants. What we mean by that is that you can delete the information whenever you want as the user, and you can decide to leave the information forever, for eternity. This type of memory cannot be written on or erased by the user without special equipment. That is, once you have that memory, because it has been programmed in such a way, as a user, you cannot do anything to alter the memory except the manufacturer who uses a special equipment. We have several types of ROM, like three or four. The first type is the programmable, excuse me, the programmable read-only memory, also known as PROM. This type of memory can only be modified once by the user. The user in this regard is the manufacturer that programmed the memory, the read-only memory, programmable read-only memory. The second one is the erasable programmable read-only memory. This type of memory can only be modified with the use of ultraviolet light by the programmer too. Then we have the electrically erasable programmable read-only memory known as EEPROM. You see, this type of memory, it is used in computers and other electronic devices to store data. And you can use it to store individual bits of data or to erase individual bits of data. These are the types of read-only memory that we have. Now, the second type of computer memory, we have discussed the primary memory. The second type is the secondary memory. When you talk about the secondary memory, you are talking about an external read-only memory. These read-only memories, they have a higher capacity of storage than the primary read-only memory. That is, they can be bigger in size. So it is usually available in form of several storage devices that we are familiar with. We have the floppy disk, we have the flash drives, we have the compact discs, we have the digital versatile discs, also known as DVD. We have the Blu-ray disc, which is a double-sided disc that can hold information on either side of the surface of the disc. Then we have the SSD, that is solid state drives. This is one of the latest storage devices that we have in town. Probably I'm going to do a video on SSD once one of these days. So the second type of computer memory that we have is the secondary memory That is, it's an external ROM. It is not inbuilt to the computer. You can buy it and attach it to your computer to extend the storage facility of your computer. Then we have the units of computer storage. The unit of computer storage can be categorized into two. We have the decimal number system unit of storage, which has 4 bits equal to a nibble. You see, when you talk about bits, it stands for binary digits. Then we have 8 bits equals to 1 byte, 1000 bytes equal to 1 kilobyte. We have 1000 square bytes, that is 1000 times 1000 bytes, is equal to 1000 kilobytes, which is now equal to 1 megabyte. We have 1000 cube bytes, which is equal to 1000 square kilobytes, which is also equal to 1000 megabytes, which is equal to 1 gigabyte. Then we have 1000 raised to power 4 bytes, which is equal to 1000 cube kilobytes, which is equal to 1000 square megabytes, which is equal to 1000 gigabytes, and equal to 1 terabyte. You see, this is the type of computer storage units that we are familiar with. But we also have the binary unit, the binary number system unit of storage. You see, from nibble to byte is the same thing. But in binary number system, 1000 bytes is not equal to 1 kilobyte. It is 1024 bytes, which is equal to 1 kibibyte. That is kilo binary byte. Its unit, or it is represented with KIB or kib. Then 1024 square bytes is equal to 1024 kibibytes, which is equal to 1 mebibyte or mega binary byte. Then we have 1000 raised to power 3 bytes, which is 1024 raised to power 3 bytes, which is equal to 1024 raised to power 2 kibibytes, and equal to 1024 megabytes, which is also equal to 1 gigabyte or giga binary byte. Then the last one is 1024 raised to power 4 bytes, which is equal to 1024 raised to power 3 gigabytes, which is equal to 1024 megabytes, which is equal to 1024 gigabytes, and equal to 1 terabyte or tera binary byte, TIB. We are not really familiar, most people are not really familiar with this unit of storage. But how does it happen? You see, the decimal number system is also known as base 10, while the binary number system is known as base 2. We are familiar with this basic binary. So how did we achieve 1000 kilobytes and how did we achieve 1024? You see, the conversion of this number system, as I said earlier, they are the same, but it reaches kilobytes. You see, in decimal number system, which is base 10, you have to multiply your base 10, that is 10, by itself till you get 1000 if you want to get kilo, because we know a kilo is 1000. That's why if you multiply 10 by itself 3 times, you get 1000. So in decimal number system, a kilo is 1000. That is 10 raised to power 3. But in binary number system, which is base 2, you have to multiply 2 by itself to get 1000, or the closest value to 1000. So you have to multiply 2 by itself 10 times to get 1024, which gives us 2 raised to power 10. I hope we now understand how the binary number system for kilobyte is different from the binary number system or decimal number system for kilobyte. Now, we have an exercise. We all face this problem when we have a problem that we buy a flash drive and we discover that the flash drive we have, let's say, is 128 gigabytes. But then when you plug it to your computer, you realize that it's just 125 gigabytes. Does it mean you have been scammed? Does it mean that the storage device that you have bought is not up to what it's supposed to be? What happened? Let's see what happened. Remember, the computer only understands binary, which is base 2. So when you plug in the computer will show the approximately converted binary storage equivalent of 128 gigabytes of flash drive, which means that the computer will convert 128 gigabytes to its gigabyte equivalent. The computer does not understand gigabytes. So the computer will do its conversion with 1024. The person that sold, the manufacturers of the flash drive, the conversion rate they used is by converting it with 1000. That's why you have 128 gigabytes. But when you do your conversion with 1024, see what we have. Now, 1 kibibyte is equal to 1024 times 1 divided by 1000, which will give you 1.024 kilobytes. So 1 kibibyte is equal to 1.024 kilobytes, while 1 kilobyte is equal to 1000 divided by 1024, which will give us 0.9765625 kibibyte, which means that 1 kilobyte is 0.9765625 kibibyte. So how can we now convert 128 gigabytes to gigabytes? Because we said the computer is showing the gigabyte equivalent of 128 gigabytes. So if 1 gigabyte is 0.9765625 gigabytes, then we just have to multiply 128 gigabyte by that value. If you multiply it by that value, you have 125 gigabytes. Now, the mistake or the discrepancy here is that the manufacturers, they refuse to adopt the normal convention of computer storage. Gigabytes, kibibytes, megabytes, they are all registered as units of storage for computer. But one way or the other, they refused to adopt it. So that's why it gets confusing when you plug a 128 gig flash drive to your computer and you just discover that it's not up to 128 gigabytes. It's not that you have been scammed. The computer does not understand decimal. So it is converting it with binary. That's why whenever you buy a storage device that is lesser than advertised, it means that the original value of it has been converted to gigabytes. So 128 gigabytes of flash drive is equal to 125 gigabytes in computer storage. I hope you understand this. Point to note too is that every computer have a different conversion rate. So if I plug the same flash drive on my computer, it gives me 125 gigabytes. On your computer, it might not be 125, it can be 117, it can be 110. And remember that all these storage devices are also programmed. So there's also a little space where the code that is used to program that plastic or that memory card or that flash drive you have bought is accommodating. So that one also eats little space. That's why whenever you buy a storage device and it's not equal to the amount that is advertised, it is because of the conversion rate and the files that was used in programming that storage device. I hope you enjoyed this video. I hope you have been enlightened. You can make more research to verify that what we have taught and learned today is true. This is ICT Clinic. I'm always yours, Benaya Akinlade. Thank you for watching.